Alright, so we have seen three different strategies for implementing generic operators. Now we'll talk about the third strategy briefly, okay? And this third strategy is called message passing, right? So the previous strategies viewed the functions as intelligent. That means that we will dispatch according to the type of data, right? And in message passing on this third strategy, we will actually do it differently. The data itself is what is intelligent, right? The data will know what to do. All you need to do is to tell the data what you want it to do. Okay, so let's take a look at the same example as before, the complex number example. So we're trying to make a complex number, x plus yi. Okay, and what happens is that we define a function called dispatch, okay, op, right, and we return this function. Now, so op, right, can be real part, then you return x, which is the real part, or it can be imaginary part, okay, and return y, okay, over here. And it can be magnitude or angle, and you return the hypotenuse or arctangent, or if it's not, then you don't know what's happening, right? So essentially what's happening here is that instead of returning some kind of basic data, you're returning a function. So the data is actually a function dispatch, okay? And this function dispatch accepts a message op, okay, and it performs the necessary action according to the operation, okay? Now, so how would you define the real part of z? You just essentially take z, which is the object, okay, and you essentially pass a message called real part to the object, and then this object itself will do the right thing. Okay, imaginary part, same thing. Well, this idea of message passing is the basis for what's called object-oriented programming, which we'll see next. Okay, and languages such as Java, C++, and Smalltalk will use this mechanism, right? And data are objects. Okay, and functions are actions that the objects perform. Okay. So these objects talk to each other by passing messages to each other. Alright, we've come to the end of the lecture today. Let me just quickly summarize what you should have learned today. The key idea in today's lecture is to manage the challenges of having multiple representations within the same software system, right? So the problems are the following, okay? Number one, you need to match the data type to the operations. Okay, number two, you need to somehow resolve the naming conflicts for the operations. And you also need to make sure that in the future, when things change, you can figure out how to change them properly. Okay, and the idea now is to introduce what is called an abstraction layer between the representations and the user. Okay, and you'll see three different strategies for implementing these generic operators. The first one is what's called dispatch on type. It's very simple. You look at the data type, you have an if-else statement, you check what data, and then do the right thing. Okay. Second thing is called data-directed programming. You look at the data type, right, and you go to this table, and you find the correct function from the table based on the operation you want to perform. You take the function, you apply it to the data. The third thing is this thing called message passing, and we showed a very simple example. The idea here is that you tell the data what to do, and you do it by itself. We haven't said a lot today in lecture, but we will do so in recitation, right? We'll discuss this in more detail in recitation. So the thing you must understand is what are the pros and cons of each different strategy. None of them is better or worse, okay, but there are some pros and cons. And you must understand how each of them resolves the name conflicts, okay? And then you must understand in each case what happens when you need to add a new type or new operation.